I want to welcome everybody today to this Build Your Simulation CFD IQ session. It's great that Heath Houghton is able to join us and talk about what's new in Autodesk CFD 2016. And I think he's also doing an introduction to SimStudio. We actually didn't talk about that before, so I do know he'll probably mention it a little bit. Again, my name is Roy Sable. I know you've talked to me in the past. And one thing I just want to point out to you with this slide is that there was a little bit of a rebranding of CFD. So in the past it would be Autodesk Simulation CFD, and now it is just Autodesk CFD. And you'll see that similar trend across a lot of the simulation products. Throughout the entire presentation, we encourage you to ask questions. We have a few people from our staff in the background to answer them live, and they'll bring them to our attention if we should probably address it live instead of through the typed question window. And as always, the slide deck will be available to download on Box with the link shown below. So autodesk.box.com/CFD14. And this is part of a larger webinar series brought to you by the technical support team. If you haven't been to one of these before, it's about 20 to 40 minutes of demo, discussion, and then QA to round out a full hour. We have three topics moving forward in our calendar. One covering cyclones, then based on a survey I'll provide everybody during the webinar. We'll do a deeper dive into one of the new features to talk about. And then we'll go into model assessment toolkit. From there, in YouTube, we post all of our previous recordings. Right here, I'm just listing a few of our more popular ones in terms of views. The last one I just wanted to share, we actually, if you attended or watched the NACA airfoil validation, we did end up putting out a white paper within our SimHub that you can download and read through to get all the nitty-gritty from that webinar. And then beyond just the live Build Your IQ and what you can watch on YouTube, there's a lot going on in the simulation community. So you can join the forums. The simhub.autodesk.com has a lot of interesting things going on across all the different products. And if you go into the events, you can see what user group meetings are going on. We have many going on across the entire country and world, by the way, as well as you'll see our webinar schedule, industry conferences, and so forth. So in the news, CFD 2016, as you probably guessed, is now available. You should be able to see your serial numbers listed within your Autodesk accounts. And just be aware, downloading is different from last year. It is moved to the Autodesk accounts like most everything. And if you go to Products and then click on your the product you actually want to install, and for CFD, I encourage you to do the browser download and then right-click on the installer and choose Run as Administrator. Flex is also being repackaged, and we'll talk about that in a moment. And in terms of some older news that I covered in the last webinar, Autodesk Subscription Center was retired on March 13th, and now everything is within Autodesk accounts. So if you go to accounts.autodesk.com, you'll find, hopefully, images similar to what you see on the right. So in terms of some recent articles that I wanted to bring to your attention, the first one is just a kind of breaking up of the suite of the Flex products. So in the past, you'd buy either SimFlex or SimMultiple Flex, and that would include a suite of the different simulation products that we had. Moving forward, that's actually going to be broken up into SimMech, CFD, and Multiplo Insight, and each one will be on their own product line. Have any questions on that? Definitely type that into the questions panel. We can dig into that deeper if that's confusing. So at this point, I'm going to hand this off to Heath, who will go over everything that's new in 2016. Here you go, Heath.
Thank you, Roy, and thank you everybody for attending. Yeah, as Roy said, I'm going to be presenting what's new in CFD 2016, and that'll be PowerPoint, but I'll talk through everything, and hopefully it'll just give you awareness on what you should expect in 2016. And then also I'll do some live demonstration on SimStudio Tools and actually coordinating that with the model assessment toolkit, which is a feature I'll talk about in CFD 2016. my screen hiding? So there we go. Yeah, I'll get started. Again, encourage questions as we go. It's always encouraged. But CFD 2016, we had three major initiatives. They're always, a way to group things to talk about what's new in the software. And if you look at the software from a big picture standpoint, we tried to make it faster and lighter. But we really concentrated on geometry and meshing, and we expanded the physics. And from a faster and lighter standpoint, there are two major areas that we focused on. We want to make you work faster and smoother regardless of model size. So there's a couple of things. One, you want to be able to solve faster. And two, you want to be able to view those models and look at results faster. So as the models get larger, you want to make sure that the graphics can keep up. So we totally put in a new graphics engine to deliver large model and performance improvements. Model sizes we've been seeing them climb significantly over the last several years, especially as computer hardware has increased and as far as the performance goes. What we did with that graphics overhaul is you should see at least a 15 to 20x frame rate increase when you're navigating the model, so that's pan, zoom, rotate. What that means is, you could put a big model, tons of surfaces, put it in full transparent, tons of results types on there, and you should still be able to navigate it easily with good frame rate speed. So it's a significant increase of performance there. And from the solving side, we're introducing our new scalable solver. Now the solver in CFD 2015 is fast, but it scales to a certain point of processors, and then if you start getting into, like up to about 16 processors, it's really fast. And then after 16, 32, 64 and above, it starts to really drop off and taper as far as the amount of returns you get. So we have this new scalable solver technology we've been working on for a couple of years here, and it's getting about an 80% scaling ratio. And then you'll notice this little graphic only shows up to about 16 cores. The reason I wanted to show this one graphic is to really concentrate on the fact that the more complex the models get, it seems that the scaling just is higher as far as getting to that ideal, which would be 100%. So I'll call it about 80% scaling ratio. What that means is if you have 8 PCs on a basic LAN network configuration, so not even a super high-speed interconnect, a basic wired network connection for most typical engineering offices. If you have 8 PCs, then they would potentially, if they had 16 cores, like 640% speed up versus one PC, or I'm sorry, it doesn't matter what the core count is, but 640% speed up versus one PC. And this is an alternate solver, so it's not on by default. It's enabled via a flag. The what's new documentation talks about it. There is a configurator for multi-node, so multi-computer, making sure that you have them all hooked up correctly. There is an executable that will help you configure this. And just to give you an idea, so I did show only for 16 cores, but this is what it looks like for us on multiple cores. This is a 9.2 million element model. And comparing speed up if you had just one core solving versus 128 cores. So you can see here that that's about 108 x speed up. That's about 85% scalability. So we're really excited. We had a lot of customers co-develop with us as far as testing this out. We put a lot of benchmarks through it, and the scalability seems to be really reaching some high limits, some high capabilities. We haven't thrown a system at it that it didn't scale well at, so we're really excited about this. Again, it's an alternate. If you have the hardware, try to take advantage of it. It doesn't solve all model types yet, so for instance, like it doesn't solve radiation, but it solves flow and thermal, transient, resistance regions, stuff like that. So there are certain analysis types that it doesn't solve, and we're adding those capabilities as we go. And the help documentation talks about what you can solve with it. So that was making it faster and lighter. One thing that we've been concentrating on as a multi-year effort is geometry and meshing. If you go to forums, if you read blogs, you see surveys about the CAE community, the number one thing that most CAE engineers spend their time on is getting a model from geometry to simplification and then meshing. And if you look at the blogs for CFD, they'll say, man, I spend about 75% of my time doing that. And so we added 3 new items in CFD 2016 to help minimize that time and effort. One is the Model Assessment Toolkit, and that's within CFD. So it's a new set of functionality which will find model issues before you start doing your setup, building your mesh, and all that. So basically, it does the things that a CAD tool doesn't normally look. It looks for things that a CAD tool doesn't normally look for. A CAD tool, when you want to do geometry checks, is just looking for kind of model integrity and maybe some interferences. But from a CAE standpoint, not a bunch there. This will look at geometry gaps, the way you assemble the model, interferences, slivers. It'll look at all of that stuff and identify them as potential issues so you know what to look for in your model. Basically, the way I see it is that if you were to send a model support, they know what to look for in a model, but they still have to kind of comb through it pretty heavily. This will do that for you, before, without, for the inexperienced user even to understand, is this model something I want to try to mesh yet? And we also added a new CAD prep tool called SimStudio Tools 2016, and this is a CAD tool that installs with CFD, and it is from the ground up for simulation. So it's to rapidly import, prepare, and defeature geometry. There's a lot of functionality there that is specifically built for simulation, and that's why I want to show it as a live demo to kind of give you guys an idea of what it's about. I've taken models here that would have been really cumbersome in other CAD tools and taken them from a manufacturing-ready model, tons of surface parts, tons of things that just you wouldn't want in a simulation, and really got it down to a simulation model in a rapidly accelerated time frame. One thing we're also doing is we're starting with surface wrapping. And everybody was on labs this summer and noticed that there was a lab project up there called Project Ventus. And its purpose is for really external aero type of models, where you can put an external boundary volume around any model, come from anywhere. It can come from surface models, come from SketchUps, even CAD types we don't actually support inside of Autodesk CFD. It'll surface wrap that model, build a mesh that's CFD compatible, and then you can import that mesh into CFD. So we included that application in CFD 2016 as well. And since this is talking about what's beyond, so you can kind of see that our focus for multiple years is going to be this geometry and meshing. So you should see more advancements in surface wrapping. You see more functionality out of the CAD prep tool, SimStudio Tools, and based on user feedback, we'll refine this model assessment toolkit. But we think that this really should help our users move forward to getting models more quickly into CFD, get it done right. So here's a quick graphic of the model assessment toolkit. This should be all new, even if you're an experienced user and you didn't get on the beta. This kind of information that you see displayed on the screen should be fairly new to you. So it's going to detect and display what I would say are potential geometry faults. So it doesn't mean that it won't mesh. It just means, hey, if there's going to be an issue, here are the areas that we suspect there might be an issue. So, I put on here on the bottom left-hand graphic, this is a piece of sheet metal with a rip in it and a very small self-gap in the part itself. So it looks at part level, what I would call potential issues, and then also at the assembly level. So in this piece of sheet metal, there's a gap, and you may not see it to the naked eye when you look at the overall assembly, but the model assessment toolkit will point it out to you and say, okay, this one's pretty bad. It may mesh, but if you don't get a mesh here, this is what you need to look at first. And then it also looks at the assembly level. And so on the right-hand side, you see a graphic, and this is a little electronics assembly. And to the eye, it looks like in the CAD model that those are mated properly. But here, it has like a less than a tenth of a millimeter gap in the mating, which could potentially cause issues. And so it's pointing it out from in a table format, showing the different parts that are listed, how much they're separated, and then also we're splashing on a legend which gives you the severity of what we consider that gap. And so you can see, as I point to a really zoomed in shot, you can see that small gap. So that's the geometry, the model assessment toolkit. From handling geometry with rapid model defeaturing and simplification, the SimStudio Tools is great for that. A lot of push-pull type of functionality. If you're aware with kind of the Autodesk ecosystem, what we have been offering inside of Inventor and inside of Fusion 360, one of our other CAD tools, a lot of this direct model manipulation, and SimStudio Tools has that and added functionality that's specific for simulation. There also the ability to do add-in apps. One of the things we're adding shortly is ECAD support, so IDF import, and this little graphic showing kind of what that user interface is potentially going to look like. Making fluid volumes. You can do that in CFD today, but it has a limit, and so there's added functionality that SimStudio Tools will add. And again, this is an associative push from SimStudio to CFD, much like you'd have with Inventor or SolidWorks or ProYer or any of the other CAD tools. The graphic on the right is something that I think is really valuable for people. You get a really complex model, and it may have a bunch of surface parts, it may have a bunch of complexity, and you know you want to simplify it. But in CAD, it may take you quite a while to do that in traditional CAD. And in SimStudio Tools, there are specific functionality where you can take and I actually did this myself, the model above, which has thousands of components, a lot of surface parts, all of those things are surface parts, and pare it down to the electronics assembly down on the right, and it took me like maybe 5-10 minutes. So to get from something like top to the bottom in 5 or 10 minutes is something I wouldn't have been able to do as an advanced CAD user that I've been doing CAD for quite some time. So I was really excited to see that this tool is going to benefit our users. So what if you have really complex geometry and you're doing an external aero in this case, and it might just take you forever to defeature a model to get it to where you want it for a CFD mesh? We're going all in on the surface wrapping. And what does that mean? It means we can take a model, pretty much any geometry, and we can surface wrap it, make a mesh, and bring it into CFD and run the model. So on the left-hand side, this is actually a file format that we don't currently support inside of Autodesk CFD. It's an InfraWorks model. It's all surface parts. It's all surface modeling, no solid geometry. And within 15 minutes, within the automated surface wrapper, we have a mesh. We're able to import into CFD and then run the setup like you normally would everything else. And then you have your flow and pressure results like you would normally see inside the model. So that's a model type that we actually don't currently support until you go and use surface wrapping. And then on the right-hand side is the actual solid model. Very complex, and there's a graphic of the mesh that's within the automated surface wrapper, and then below the results. Again, a model that would have been tedious hours worth of work, taking very little time within the surface wrapping functionality. So we're excited about those things. What we also have been doing with Autodesk CFD is we're expanding the physics as we move forward, and a lot of those are coming from customer requests. From the forums, from Idea Station, talking with industry insiders, whatever. But one of the things we noticed was for our AEC type of customers, people doing thermal comfort, doing energy studies, that our solar energy transmission through windows, in particular, was as a globally correct, but locally not detailed enough. So what I mean by that is solar energy transmission came through windows, but you didn't see the imprint on the floor, you didn't see the localized effect. It was diffuse into the building. And so we went through the task of correcting that or filling that gap. And more importantly, as we did that, making a highly efficient workflow for doing these solar energy studies with thermal comfort or just pure energy usage. So there's a new material model, and we call it solar wall or solar window, and it allows you to put in your inputs for the solar energy transmission in the data that you would get from a manufacturer. So instead of going through and making a material science project out of it, putting in wavelength dependent emissivity and all this kind of stuff for solar, what do the manufacturers put out? They put out a solar heat gain coefficient, and they put out a U factor. So we allow that as the inputs, and you'll see on the left-hand side here, that's the shadowing from the sun, and here you can see where the same bright spots are in the image. That's the solar heat flux inside of Autodesk CFD. So you can see where you're getting that localized heat flux imprint. In addition, what we did is, by streamlining this workflow, we removed the necessity, if you're doing an internal study here, to have that exterior dome for these solar studies. And I think equally as important, if in the past, if you wanted to put the exterior ambient without having that exterior dome on the building, you just select every exterior surface on whatever you're modeling, and then assign the boundary condition. Well, we decided to allow the software to automatically apply the exterior ambient with just a reference temperature. And then you can override it if you want, but automatically apply that exterior ambient. So saving you potentially hundreds of mouse clicks and a lot of setup time. So we're pretty happy about that. There's the feedback from our, again, we co-develop these with customers. We get with some industry insiders, and they're pretty pleased with the overall functionality, and I hope you will too. So other expanded physics, we added accurate high curvature flow modeling. So we added 2 new turbulence models. They're, I think we have these for as a hidden flag for a while to let guys kind of mess around with them, but we added them completely to the interface. So they're what we call curvature correction or rotational correction models, and SST variants. So one of them's a Smirnov Mentor and one of them's a Helston. Without getting into details of what's in them, just suffice it to say that before, when you try to do something that has a lot of curvature, like a cyclone separator or these Coanda airfoils, you might not have gotten that vortex core well defined enough in order to have as accurate as possible of a model. And with these new turbulence models, you can see the core is fully developed, and you get much more accurate results for these specific, really complex flow cases. We added that as well. Every release, we're also going to concentrate on what we consider gaps from the user experience standpoint. One thing we were finding is that the decision center wasn't discoverable enough. New users weren't using it, so experienced users making great use of the decision center, but maybe new users not seeing where the button click was, or for instance, or stuff like that. So we improved the visibility, moved it up a layer to the ribbon tab. We added summary parts for all material devices. So if it's a, like a compact thermal model had it, but maybe fans or resistance parts or whatever may not have had all the functionality. So all summary parts for all material devices are available, and it simplified the ability to put in, to select which entities are in that table, for instance. Results entities, improved identification. These are all what I consider, if you looked at one, they're kind of small things, but overall, your overall experience and satisfaction with using the tool should be highly improved. So we improved naming identification and improved the way the design study tree works. Added things from the idea station, like, hey, I want to be able to export particle traces as a movie. Okay, well, here you go. One thing for people who are using adaptive meshing, we really sped up that process of the actual adaptive meshing, mesh creation. So if you're doing those studies with adaptive meshing, which is a great tool, you should see a significant increase in speed up of the time it takes to mesh that first and second and third iteration. In addition, some improvements on surface auto sizing. So here's an image of the of what we would call an airfoil with a singular surface. What that means is it has no edges on it. And you might see in the past some choppiness at the edges. So we went through and tackled the complex surfaces, improved the surface auto sizing capability to grab those that complex high curvature surface and be able to define the mesh properly on it without over-meshing the portions that don't need it. We improved all the in-product messaging, so the toolkits are much more descriptive. and solver notifications. So if something wasn't set up right in the model, we tried to intercept that and give you not just a, hey, it didn't run, it didn't run because of X, Y, or Z. That's always an ongoing process, but we tried to really improve the in-product messaging. For all of our Flex customers, there were considerable improvements in Flex over the past couple of years. So in 2015, you should have seen an increase in reliability on your upload and download. So if I ran a result, do I get the results back? So really concentrated in 2015 and continued that concentration in 2016. In addition, we upgraded the data transfer just in general, so that there's smaller data size that has to go back and forth. We're more efficient on packaging that information together, and so your upload and download time should be not only more reliable but faster. And in addition, we upgraded the worker instances. So if you're using CFD Flex 2015 and you upgraded 2016, you should know a significant increase in solve time speed up. So here's a little chart below, there's a graphic and a chart below, but basically here's some metrics. Now this bottom one's a really small model. It's not even 1 million elements, and it's getting about a 20% speed up. But you're talking about a 20-minute solve time. So the larger models, we're seeing most people push their models with using CFD Flex to the cloud solving. So there's a 6 million element flow and heat transfer, a 1.4 million element model with radiation and buoyancy, all the physics combined. We're seeing about a 50% speed up, a 1.5x speed up. So saving yourself, for instance, in this one model, I think this is the radiation flow and buoyancy model, it's like 2.3 hours saved in solve time. So you can see significant improvements on your cloud solves. I went through that quickly so that I could go, or as quickly as I could, so that I could do some live demonstrations. So that's what I'm going to do now. And I'm going to show some functionality in SimStudio Tools.
So before you dive into that, let me just ask everyone a quick question here. Now that they've seen that list, moving forward in terms of our schedule with the webinar series, just curious, which one of these new features would you want us to dive in deeper first?
Yeah, so the ones that are going to be, for everybody. So I think you're already going to be looking at.
I'm putting a poll question out.
Oh, I got it. I was like, oh, my.
Yeah, so just so you know, if you don't see the poll question, it's new and expanded physics, configuration, or more information about the scalable solver, more demos into model assessment toolkit, SimStudio Tools, and looking at the mesh surface wrapper.
Okay. Yeah, I'd be interested. Yeah, so that's great. You want me to pause before I start the demonstration, let people answer that?
Yep, so let's give them another 5 seconds, then I'll close it.
Okay.
Yep. There we go. So I'll just share those results everyone sees. Over resounding vote for SimStudio Tools at about 33%, and then a model assessment toolkit after that. So yeah, those actually go somewhat hand in hand in terms of the geometry side of things. So we'll look at those first, and I'll hand it back to you.
Okay.
You might need to share your screen again. Oh, there it is.
Yeah. Do you think I should, there's a couple of questions. Are you guys answering those in the background?
We are answering them in the background. One, I thought you might be a little bit more detailed, but in terms of if you have a similar setup between the older and the newer solver, what would you see in terms of a speed up? If you have a 8-core machine and you run the model twice.
Okay. Yeah, with scalable, so I want to be clear to everybody that's on the call, the scalable solving doesn't mean it's faster when you only have about 8 cores, right? The current solver takes high use of resources there and is very efficient. So for smaller models, for models that are running on an 8-core machine, I don't expect a significant increase on the scalable solving. It's when you have more compute resource available, multiple computers that are on the same network, or an HPC environment, so high performance computing environment where you have a blade, a cluster, or something. That is when you should start seeing significant increases in performance from the scalable solver versus the current default So I would expect an 8-core machine. You just run the solver you have today. Now, you get 2 or 3 machines, all of a sudden, yeah, I would test out the scalable solver and run it, because you should see a performance increase for yourself.
Cool.
Yeah, cool. Yeah, so let's do the SimStudio demonstration here, and just to show you some functionality. So this is the SimStudio Tools. This is a simple model. I actually have a whole bunch of stuff hidden here, but this is the board that I was showing earlier in the PowerPoint. And what I want to kind of emphasize to everybody is it has some functionality that you kind of wish other CAD tools had. So in default, you put in a dumb model, it comes in all gray, so it's really hard to see what's going on in a model, right? So I can cycle, color cycle, which gives me random colors on all the components. Components that are instances of each other will keep the same color, so you can kind of see these are all instances of each other. It just helps you to kind of determine what are you looking at, first off. And for this model, I just want to show everybody there's a ton of components. They're all surface parts, and I would never send this over to CFD because it's just too much detail. So one of the things you can do is select by size. So the smaller stuff I typically want to get rid of, and I'm just going to select everything that's 2.5 millimeters. I want to make it easier for everybody on the webinar to see. I want to make everything that's gray again by undoing the color toggle. And you can see all the blue things or what just got selected. So all those things, and from that standpoint, they're selected. I'm just going to hit delete. So I could hit delete on my key, but I want to make sure everybody sees what I'm doing. So I'll just hit the little delete button. So the keyboard shortcuts are there. So I just deleted all the little tiny things that are kind of in detail. You still see things sticking through because some of these components are still real complex. Now, from a CFD standpoint, this is pretty slick. This is something that you will not see typically in other CAD tools, and it's a replace with primitive. So I have all these fuses. They're going to produce a little bit of heat, and what I want to do is replace them with a simple shape, because again, if you look real closely, they're just surface parts. I need a solid body for CFD. So replace with primitives, just grab one of them, put the box that bounds the bounds. Now I could resize the box, I can make it a cylinder, I can do whatever I want. I'm happy with a box. I'm going to replace all occurrences since there are a bunch of these guys, and I'll hit OK. And you can see within a couple of seconds now you have a box for all of those guys. So now I have my simple component. And I can go through and do that for a lot of the things in this model. So I'll grab this guy. Simple box is fine for me. Now this one has some protruding little pins. So if you were to look at it from a different angle, kind of protruding a lot further than what I really would want. So again, push-pull technology, I can make it conform a little bit more to the general size that I'm a little more happy with. And OK, and we'll replace both of those guys with the box. Now, once you see something, that box protrudes all the way through because the pins came all the way through. So I didn't adjust this bottom portion, but this is kind of cool. So I'm going to grab these two edges, right-click, press pull. So grab my grab handle, and well, I can grab it and move it up and try to position it right. But if I just click on the surface, it'll snap to it. Now I have it perfectly positioned. So I can go through with this model and quickly do all that kind of stuff. So again, more replace with primitive, grab one. That box is fine. Hit OK. All the red guys will get replaced. I can work through and do that again for multiple entities. So hopefully, you guys on the call that are doing electronics or anything, for that matter, will go, wow, now that truly is very helpful, and I could do this for about 10 more minutes, and this model will be completely done. But what I want to do is move on, because I have multiple things. We're at a limited time frame here. I have another model open. So this is have you ever heard of the 3D printer called the Autodesk Ember? This is the bottom housing, and I have a couple things hidden again just to get to where we show off some things in CFD. And I want to do a little bit of demonstration on the model with this toolkit here. But one of the other pieces of functionality is sometimes you have complex parts like there, all these embosses. Now I could go click on individual faces, but there are a ton of them, and start deleting to get rid of that detail if I wanted to. Or I can use the simplify tool. So remove features, click on my part, highlighting what it's, I can remove just a little bit or a lot. I can tell it type of feature I want to remove. So I'm going to remove all of that embossing there. Hit delete, it's gone. So real quick and easy tool there. Again, the drag capability, we can do all that stuff, but let's go ahead and let's send this to CFD. So something new for everybody. Because this model assessment toolkit is supposed to be, we want all the new users to use it to understand if their model is ready. We made it the default, the bigger button, the bigger icon in all of your launchers from your CAD tools. Now you can override it by going to the smaller button like Simulate. But if you see it says Model Assessment, it's going to actually throw it into the Model Assessment toolkit and before you go into the setup environment. So CFD is opening up. It's a live demo, so it's going to start working for me immediately. And take just a second for it to push this over. So what you should see right now is it actually automatically starts doing some assessing of the model. So we're looking at edge links, surface slivers, model slivers, part gaps, which I talked about in a little bit of detail in the presentation, and then model gaps. So it's going to go through these assessments. What's nice is I can actually start working on the model before it finishes all the assessments. It's an asynchronous, what we call an asynchronous workflow. So I can start looking at things like edge length while it's still doing the calculations. And I want to be real clear, you still have to use engineering judgment, but we give you the ability to say, okay, you know what, anything below a certain size, I want you to point it out. Right now, it looks at the overall size of the assembly you threw in, and or that you loaded in, and it gives you all of the features that are below that size. Well, in this case, I really only care about the really small things. Now, I don't think CFD really has a problem meshing small edges, but what it does is it causes you sometimes to have an inefficient mesh, and so we want to just point that out. So what we call them potential issues, not necessarily that it's going to cause a mesh to fail, but that it's there. So in this case, and we have a lot of ways to visualize this. So we have the way to emphasize the part. It's interactive in the model, so we can emphasize those parts. We can have it isolate the part. We can have it zoom into the actual potential model issue. So in this case, zoom really far in. One thing that I actually like to do, and for me, just because I like to keep everything kind of around this table, I'm going to go ahead and zoom fit. So I like to zoom fit. So that's pretty far out there, right? If I zoom in, really in there, it's a small feature. If I zoom out, you can see that there's a small little step gap in that little fan housing, or that, I'm sorry, this is the projector housing. So this is something, again, it's not something that you would see with the naked eye. We're going to point it out, and then you can go back to CAD and kind of clean that up. We don't clean it for you, but we point it out to you, and it's something that you would probably never see unless you strained your eyes for hours on a large assembly model. So go ahead and unisolate this guy, unzoom, go back to the model itself, and I can look at the edge gap. So again, it's been running through these assessments. I'm not going to go through all the assessments, but one that I would look at is these part gaps. So let's look at the part gaps table. And again, it's going to go to this default separation distance. I'm going to pare this down a little bit because I want people to get scared. We show the potential model issues, or there's it's hundreds, but it may be looking at the overall model size and saying, hey, you know what, there's a lot if you increase that size pretty heavily. But let's look at maybe this one right here. So here's a potential model gap, and again, just demonstrating what we're looking at. See it. What I would suggest for all of our users is if you see a large band, when you look at gaps, if you see a large band, not just like a little tiny painting, but a large one, then that's where you potentially are going to have an issue. So if I go to here, I click on this guy, and I'm going to zoom out for the model. It's these two things that get close to each other, but it's barely painting them. you can use your engineering judgment to see that that's not really an issue. It's just because the way we calculate it, it just shows that things get close. But they're not close over all large areas. I go to this guy again, and because of the way it's configured, we're pointing it out, and yeah, that's truly a really small gap. And actually, if I rotate this model, it's very hard for me to show the gap that's actually there. 0.01 millimeter distance, and it's over a considerably, what I would consider a considerably wide area. That's one that I would want to go back to CAD and fix. Hopefully that makes that clear. And as we look at the model, you can see again it was running as I was going. So I can look at model gaps now. So let's look at the model gaps. Some of the things I'm not going to mesh, I don't really care about, so it's looking at the parts. But when I look at this overall model, then there's a couple of things that I thought were mated that are not. So it's showing me a model gap here. And if I even bring this down even further, I can actually see what the actual gap is. So barely showing up is 0.1. So this is about a 0.1 millimeter gap. If I want to isolate different parts to see if they're okay, I can do that. But in this case, go ahead and click on these guys, and it should start to auto-isolate for me some of these gaps. So one of the things to point out as well is look at this one. Now, I thought this assembly was pretty large. I'm going to actually isolate it because this is a complex model. This guy, whole region, may not come over real well on the GoToWebinar, but you can see this whole region is a gap that's 0.1 millimeters. Not the greatest thing we want there. Now, this model actually meshes. I was surprised. Our mesher handled a 0.1 millimeter gap for a large region. But if I were to have a failed mesh, that would be the biggest red spot I could find on the model. That's what I'm going to go look at. And so, matter of fact, let me make that a little easier to see for everybody. So I made that part shaded. You can see again that large swath of a gap that's across a large portion of the model. So we're just trying to point out what is potentially an issue, and hopefully, with your feedback, we can make this tool even more user-friendly. We think it's a really good first cut. It's actually like a second and third cut because we really concentrate on it really heavily in beta testing. But want to just kind of show you again. So go back and isolate. What's one thing that I could quickly fix? These three guys right here. If I were to again look at them in the model assessment toolkit, see those three guys. Go back to the SimStudio Tools. Just fix that real quick. So I hold down my mouse, I'm going to grab that face, press pull, and I'm just going to click on the surface. It was exactly 0.1 millimeter. I can do the same thing for the rest of them. So that's my kind of a quick demonstration on what some of the functionality within the tool. One of the things you'll notice in here is that even though it is push-pull type of functionality, which we can suppress and unsuppress parts. So when you're actually sending things over to CFD, you can have model variants based on suppression or unsuppression of your model components. And there's tons of other functionality that you should. One of the things that I found is sometimes you get some really complex parts, and what you need to do is actually unhide this one part. That's not it. This guy. So if you have a really complex assembly, what you might get is stuff that didn't come over properly. We have a bunch of surfacing tools within here for repairing and auto-fixing, and it can become real handy when it comes to fixing. When you look at a model, you're like, that is not what it should look like. Be able to delete, restitch, and use gap fill and stuff like that. It was really beneficial for me. So like this part, for instance, when I first got it from SolidWorks, I had a bunch of stuff that other tools, it would have taken me a long time because I'm not a surfacing expert, but because it's built for simulation guys, I was actually able to go through and repair some really funky stuff that was happening in this region for whatever reason when it got translated. I think that's about it, Royce. Just want to show a little bit of the model assessment toolkit, a little bit about SimStudio Tools, and the functionality and why people should test it out and see if it works for their workflows. I think we can just kind of open up to questions.
Great. No, thanks, Heath. That was all very good. And we've been answering some questions in the background as well.
So I have a question pane here. Do you want me to? So a lot of these have been answered, I guess. You guys have been killing it.
Yeah, we've been on it. We had some good comments in there about, really happy to see that, there was a Fusion 360 to, since that's what SimStudio is based on. They like to see, they're happy to see the integration with all the Sim products.
Yeah. So I'm sorry. I was also reading notes. You said the SimStudio integration.
Yeah. No, they're just happy to hear that it's that it's there. That's the direction we want.
I think what you will see is what we saw from a product standpoint is Fusion had some great, Inventor Fusion had some great promise, but we didn't have a lot of control over, some of the functionality there as a product because it was built for Inventor, not for CAE, not for simulation. There was some great functionality there, but now this is built just for simulation. So the things like the simplification tools that are geared towards how a TA guy, a CFD guy, a MOFO guy, how they would want to de-feature or simplify a model or suppress parts, stuff like just being able to toggle the colors on and off, to see what different components do. Just simple things that just make your life easier. We have a lot of control over it. So I think the users hopefully will see those benefits and really reduce their amount of time. Again, the whole point is we don't want to make a huge exercise of taking your geometry, getting a mesh, and running the simulation. We want to get you the result as fast as possible. So, we can tackle on the geometry side. We can tackle on the meshing side. We're also tackling it on the surface wrapping side from the CFD standpoint. And we should see drastic improvements this year, next year, and the next year. My goal is I don't want anybody to even think about mesh in the future. Like, oh, yeah, remember we used to talk about mesh all the time? Well, now I just hit the button that says mesh it and adapt it. I'm done. That's where we want to go.
Hey, Heath, simple question here. Can you just show the export options from SimStudio in terms of step, IGES, what you have available to? There's a huge list that I seem to remember. It's pretty much any of the standard file options.
Yeah, so this is for exporting. So you get IGES, step, SAT, PWD. So you can archive these guys, whatever. This is a standard export. The tool is meant mainly to go into our simulation tools as far as exporting, but these are pretty standard export options.
Yeah.
The most important part is what are the import options, right?
Yeah,
so,
yeah, that's a good point. That's even a longer list.
Yeah, it's a huge. You can import alias files. Just tons of things you can bring in. So I think that's really the most important part is that I can bring in.
We have a couple education people that have joined as well, and they're curious when CFD 2016 will be available for that community.
For education, well, we just launched CFD last week, and I actually don't have that data off the top of my head. I think I'll have to defer, and whenever the education community gets all of the updates.
Yeah, I seem to remember it took about a month last year, so it wasn't instant.
Yeah. But yeah, I'd say just continue to check your Autodesk account. I'll try to get that information. I just don't have it off the top of my head.
Can you load Revit in directly from SimStudio, or you have to save out an ASIS first and then load that in?
Yeah, that's a good question because I haven't tested that workflow. Actually, catch me on the fly here. I'll have to look. I believe you have to actually export ASIS.
That's what I thought too. Yes.
Yeah, that happens to be the case.
Yeah, so you'll have to export from Revit as an ASIS, which is basically what we do in the background when we read it in the CFD, and then read the ASIS file into SimStudio at that point.
Yeah.
Hey Gary, we'll do a wrapper example in another webinar, kind of run them short in time, and that for some models it's not as quick as others. There's a lot of things going on in the background for it to make it happen.
I think the thing that I would do also, if you have a Revit model and you're wanting to know, diagnostically, you can go into the model assessment toolkit with the Revit model directly, and from there you can see if it's stuff that you would want to fix in SimStudio Tools, or if it's or if it's fine, and just move straight from Revit into CFD. But yeah, if you're going to go into SimStudio Tools for that workflow, you have to do an ASIS file.
So when it comes to SimStudio licensing, this is actually a good thing to point out. I don't think it actually checks anything out, and it doesn't know if multiple people have things open, but it does look to see if there's a simulation product in your license server. Okay, so correct me if I'm wrong, Heath, but let's say you had 5 people install CFD on their machines, and really they only had one design study environment license. Technically, each one of them could have SimStudio open at the same time.
Yeah, it doesn't consume a license. It just checks to make sure you have an entitlement to one of our simulation tools.
Right.
So that could be a Flex license. It could be a name, that you're signed in to Flex, or into, you're signed into your account for Flex, or that you have a perpetual license on your network that you can tie to. So it's very flexible from that. Or if you think Flex, it's very easy from that standpoint. You don't really have to do anything from a licensing standpoint other than be able to run one of our tools.
Mm-hmm. Okay, we have about 5 more minutes as people start thinking of any more questions. This is actually more for my own entertainment. I always kind of like to think about, where people have come from in terms of history. So when did you first start using Autodesk CFD or CF Design? And, were you pre-acquisition, when it was still CF Design, 2011, 2010? Or when did you come into, one of the Autodesk branded products?
Is that a poll you just released?
Yep, another poll.
If I open that, do I see that poll, or?
You probably have to expand your GoToWebinar window, and then you can probably see it.
I don't see it, but that's okay. I'm good. I see it now.
Okay.
There.
Okay, so I'll close that out. I'll share that one as always. And it's actually a pretty good mix. The largest group here is actually the CFD 2014, and then 2012 and pre-acquisition were both about 25%.
Yeah. I always appreciate the CF designers and the new guys. I can't tell you how much I go around the world and talking to customers, and they still call it CF Design, even though it's been in the Autodesk family for 4 years.
Oh yeah.
Yeah.
We see that in support.
Yeah. Well, this has been great. I guess if there are any questions, I would say the forums are great for people to get in on and ask questions about new functionality. We typically see a highly increased rate of traffic after a new release. So I totally expect that this year as well, especially with workflows that are completely new, like the model assessment toolkit. If you're doing thermal comfort, the radiation, solar radiation, I expect that people will have questions on how to use that. The help system should be very detailed on those. That's what we concentrate on. The help is stuff. But if you have questions, feel free to go straight to the forum. We'll be watching out for those questions for sure.
Okay. Great. Well, thanks again, Heath, for presenting today and everybody for joining. At this time, there's no more questions, so I will end the webinar, and we'll see you again in about a month. Bye, everybody.
Thank you.